Hello to everyone. Let's look at the papers which are to be presented this year. One of our researches at Klubukani, which is the embedded data acquisition system for logging and monitoring of PV parameters. The objective here is to use a microcontroller uh, to monitor and log PV produced electrical power, monitor and log rooftop top temperatures, and as well as to monitor the batteries. So it's sometimes important as we collect the data from solar resources to check if the battery is being charged and it will be able to cope with the load supply. Now, as far as our method is concerned, we'll start with the temperature sensing. In this research, a Delos temperature sensor is used, uh, which comes with the libraries that you can download online. They will translate uh, the signals being read onto meaningful values that will uh, be transcoded by your sketch to form a temperature as requires. In this case, that was in degrees Celsius. And the second part of it was how do we sense the power produced by solar. We used a small solar panel right there. In fact, it's actually a solar panels which are installed in the roof that produce a voltage across them and supply a certain current. From there, we pass through a compact current voltage sensor, which will will detect the current and also detect the voltage. After using the sketch to translate this onto meaningful values, we use the full power formula VI, and then where VDC is the voltage produced by panels and IDC is the current produced by panels, that will be resulting onto the power produced. For more information on the compact uh, voltage current sensor, you can go to this website as reference. And the battery level sensing, we use the LM7809, which is a 9-volt regulator, taking advantage of the fact that an open voltage of a fully charged battery is about 12.7 volt, as highlighted there, and for an for discharged battery will give you around 12 volts. Now, voltage divider rule or Kirchhoff's law, if across the regulator we've got 9 volts and your input is 12 volts, then the output will result from the difference of the two, which in this case will be 3 volts. So 3 volt will indicate low battery. Now, if we have a fully charged battery, this rises to 12.7. Now the difference between that's the battery with 12.7 and 9 volt will give you 3.7. So 3.7 as read by software will indicate a fully charged battery. So we can work out any intermediate values using tables which were done by previous researchers. So that's how the battery level is detected. We move forward looking on to what the Arduino sketch do, software algorithm. At the beginning, you will read all sensors, and then after that, you use appropriate equations, that one of them being listed as IDC times VDC, to work out uh, the output power. Um, in a case of the level, battery level, we subtract from the input of your battery 9 volt, and then you get the what is used to represent the charge level, which range from 3 to 3.7 in our example. And then after all, you send the values via a serial port for logging onto PC. You can use existing software such as Hyperterminal for the logging, Cool Terminal, and as for the display, you use an LCD to display the output values. So these are our results. In the case of logging, it was found that the voltage will fairly remain at around 12 volts. It can go above that during charging, but then and the current can go up to 10 amps. Now, at any time, if we want to calculate the power, we're going to use the formula VI from the solar panel of 200 watts. You can see there. If we look right there, we have got about 114.2 multiplied by 10 amps, and then which gives you 142 watts. Make sense? And in another result, an LCD is displaying a current of 14.9, roughly 15 amp, which comes from a power produced of about 188.54. So with that you can work out what the voltage is by taking power and then you divide by current, and the temperature is at 26.7. So these are the conditions. Of course, the temperature will have an impact onto these results. You might come and then you see the temperature stating is 6.7, and then it drops the power, it drops everything. Now, in conclusion, we managed to monitor the power using the microcontroller based tests. This is a data acquisition system, and proper formulas used in our sketch to calculate the values as required. And well, what will this mean? If you have your profile the performance of your solar panel, you know what to expect. You're gonna be able to tell whether your solar panel deteriorate and do upgrades, or if you want to build a system similar to that, you know what to expect, what to adjust. And then again, we learned that the battery level can be detected using an LM7809 if it's a 12 volt. So for other application, if you want to we calculate, estimate the remaining battery level, you can use voltage divider rule, where some voltage 9 volt is dropped by LM7809, and the rest will indicate the available charge. With that, we come to the end of our presentation, and looking forward for you to attend the next one, and goodbye.